What is up, Riley from Riley's Reviews. Today we're going to be doing something super simple but very substantial in terms of your computer engineering degree. It's understanding and building a memory module. So what we're going to be doing today is just building a simple 2x2 memory module that we can write to with probes that will show what's in it. We aren't going to do a readout. And then at the end I'm also going to explain how to scale this up to, say, a 4x4 memory module, or an 8x8 memory module, or even a 16x16 memory module. It all scales up. It all does is decoders, encoders, and latches. It's super simple. So right here I got LogicWorks loaded up. So we're going to create printer error. Oops. Anyways, so basically the whole premise behind a memory module is going to be latches. They are what store the information. In our case, we're just doing a 4x4, so it's not going to be super challenging. Sorry, I need to drop this down. There we go. We'll make it a little smaller. There we go. Okay, so here we got the 4x4 memory module that we are going to be designing. So here's one latch, but we're not going to use this because this has this set, which we don't need. So here's your data write, your clock / write cycle, your reset, and then your out, Q out. But we don't need, well, I guess we'll use it, it's fine. So here's, and then here's another one, here's another one. It's easier to put them in a grid array just for the sake of being able to understand it better. And then here we're going to put probes in, binary probes. Can you guys see that? Yes, you can. We're going to rotate these to the right for simplicity's sake. And we're going to copy this guy, paste him right here, paste him right here. Otherwise I'm matching up. Okay, beautiful. So those are all set to go. This needs moved down. This needs moved down. You guys want me to space this out a little bit? I think I would do nicer. There we go. Okay, so this is gonna be our num1 high most sig bit num1 least sig bit num2 most sig bit. And that sig stands for significant. 2 least sig bit. Okay, so that's good. We're good to go there. Now we're going to make our data probe, or our data write, what we're going to be putting into the switches that are going to control what we're writing into the memory module. Oh shoot, I don't know what happened just there. Oh, we just centered it. No big deal. So there we go. Now we're going to do 2 more switches. So this is going to rotate to the right. Cut, paste, fit that a little bit better. Okay, so this right here going to correspond to the data write on the first 2 least significant values. So we're just going to connect these here, just like so. And then this is going to correspond to the data write on the most significant. Just like so. There, that's all done. So now we can select, now we can put in our value. 0, 0, 1, 0, 1, 0, 1, or 1, 1. Now we have to have some way of activating which one we want to write to. The first one or the second one. Which register do we want to write into? So to do that, in our case, we are just going to do something extremely simple because it's only a 2x2. It's literally just going to be this, a switch. I'm going to put this down so it's a little more visible. So it's just going to be a switch with a Very simple connection. So this is going to toggle the high value to here. And then we're going to also run, I'm just doing double lines just to show you better so you can see visually what is happening. I'm going to run a cable there. And then in our case we want to run this down here. This is going to, but we don't want this row right here, we don't want the second row to be activated. So what we're going to do is we're going to search a knot, just a simple knot gate. We're going to rotate this to the right, just like so. Super easy. Just like that. And then we're going to connect this to the cycle right on these. So just like that, it's all good to go. And then we are also going to, yeah. Beautiful. So now we can select either the first one. So right now we're selecting the first one. And then second one. And now we just need to connect the reset. So reset. Oh, sorry, I'm searching the wrong thing. We just need to switch. Binary switch. So this is going to go to our reset. I'm just going to type reset right up here. Reset. Okay. Reset. Why is that not set? There. Beautiful. Then we're just going to tie this to all the reset pins. Super simple there. But just like that, it didn't connect right there. Okay. So now everything's set as 0 because I've just toggled between both of them. And reset is active on low, so right now it's off. On, off. Notice how it resets everything to 0. So right now we're going to leave it off. So now notice how right now it's 1. So that would be this row. And the data value is 1, 0. Works perfect. Now we want to go to, say, the second row. Notice how it instantaneously changed it to 0, 1, or 1, 0, the same as up here. This, if we had a set up top, you could set it so that this wouldn't actually instantaneous change. You could put the set on 0 or low, inactive, and then when you wanted to set it, you could. But in our case, it really doesn't matter because we're just talking about the general principle of it. So now, let's say we wanted to make this a 1, 1. There, so now it's a 1, 1. Value in here stored as a 1, 1, super easy. So next thing you'll notice is that, notice how this stuck. There's a 1, 0 binary 1 value, or decimal 1 value stored in that. Now if we go back to this, we're going to toggle back to row 1. Notice how it instantaneously changed, but it also stuck the 1, 1 or binary. Yeah, binary 1, 1, so it's stuck in the second row. So basically this is the general principle behind it. It's really that simple, guys. That's all you have to do. And then in terms of scaling, say you wanted to make this a 4x4, so you wanted to, I don't know how we're going to do this quick. So if you want to make this a 4x4 for say, you're going to just do this. All you have to do is copy, paste. Hopefully it shows up on your guys' screen. I don't know if it's going to. There it does. Okay, perfect. So you're just going to copy and paste this, and then you're going to make this, 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 this. So you're going to make a 4x4 grid. Up top, instead of 2, copy, instead of 2, you're going to have 4 inputs, one corresponding to each column. So it'll be column 1, column 2, column 3, and you're going to connect these to the D data write, or data on the latch. Same thing, you're connected across, and then what you'll want to do is, instead of just having this toggle back and forth, you're going to want to get a decoder. So in our case, you want to get a 2 to 4 decoder. So you're going to have your rotate. So now instead of just the one toggling between binary 1 and 0, you'll have these two, which will then toggle 0, 0, 1, 0, 0, 1, and 1, 1, which will correspond to Q0, 1, 2, 3, and that will correspond to each column. So you'll be able to activate column 1, column 2, column 3, column 4, and you'll connect this all the way across. So these will go all the way across to all the clocks. In terms of reset's still the same. It just connects to every single one, so that could be a little meticulous. If you had a bus line, it would be very nice here, and you just run them across. Then you run them across, and then you run these across, and then these across. There also may come a situation where professor would want it to be tied to a clock. So what you'd do with the clock is you would just have a clock, and then on each input, if you wanted to write on a clock cycle, for this to be true, you would have to set it up so that there's an AND gate between each one. So you'd have your outputs. Each individual output would have an AND gate, a 2-input AND gate that goes to rotate right. And so this would go to, say, copy, paste, paste, paste. So all these are tied to the clock. So this is going to be tied to the clock. All these are going to be tied to the clock. Clock, 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 clock. And then each one of these inputs would go, or outputs, excuse me, would go to the input of the 2-input AND gates. So you just go like this, and then they would go to their corresponding row. That's all you do. And then you put it into your clock. Clock, clock, across. So this would go to this row, this would go to this row, this would go to this row. So in summary, basically all you're doing is, if you're scaling this up to a larger size, is you're adding a bigger grid of D latches. You are putting a decoder at the beginning instead of just a switch. So you are increasing your outputs so you can select different rows. If you want to make it even bigger, you could use a 8 decoder. So in this case, you could do 8. So you could do an 8x8. 64-bit memory total bits of storage, or you could store 8-bit values, and then up top, since you have 8-bit values now, you would have to have 8 inputs, so this would double, so you'd have a lot of inputs there. But that's basically how it works, guys. Like if you like, subscribe if you want to see more videos like this. Thanks for watching. Stay techie.